Today, we're going to talk about how you can use Venn diagrams to show that a particular inference is valid and to explain why it's valid.
Yeah! All right! Yeah!
We're going to do that by considering the particular inferences, the particular arguments that we looked at the beginning of last week when we were starting our unit on deductive logic. So let's look at those inferences right now. Remember, the first one was the example that Walter gave back in week 3, our argument about Mary. Premise 1 was Mary has a child who is pregnant. Premise 2 was only daughters can become pregnant. And so the conclusion of those two premises was, therefore, Mary has at least one daughter. Okay, now, how do we represent the information contained in the premises of this inference using a Venn diagram? Well, let's begin by asking, what are the categories that this inference, that this argument brings into relation with each other? Is Mary one of the categories? Well, no, because Mary's not a category. Mary's an object. Mary's a thing. She's a particular thing. She's not a category. What is a category, though, that's mentioned in this argument is Mary's children. And the information in the first premise is that the category of Mary's children includes something that is also in the category of pregnant people or pregnant beings. So we can visually represent that information as follows. The category of Mary's children includes something that's in the category of pregnant people. Right? So we don't know whether or not the category of Mary's children includes anything out here, but whether or not it includes anything out here, it's got to include something that's in this region. So do we draw an X? Well, let's wait a minute. Let's ask, where would we draw that X? Would we draw it here? Or would we draw it here? That's going to make a difference. That's going to make a difference where we draw it. So we don't yet know whether to draw the X in here or in here. We know, though, that the X is supposed to go somewhere in this football-shaped region that's in the intersection of the category of Mary's children and the category of pregnant people. Maybe premise 2 will help us figure out where to draw that X. Let's see. So premise 2 says only daughters can become pregnant. So how do we visually represent the information that only daughters can become pregnant? Well, only daughters can become pregnant means that there can't be any pregnant people who are not daughters. So we have to shade out the circle, the portion of the circle of pregnant people that's outside the circle of daughters. Right? There can't be any pregnant people who are outside this circle. All the pregnant people are inside this circle. Okay, but remember, what did premise 1 tell us? Premise 1 told us that Mary has a child who's inside this circle. So here's what we know. Mary has a child who's inside the circle of pregnant people, and anyone who's inside the circle of pregnant people must also be inside the circle of daughters. Well, so Mary's child, who's inside the pregnant people circle, must be right here. So that's where the X goes. So what we can figure out from just the first two premises, remember, I haven't relied on any information here other than the information given in premises 1 and 2. What premises 1 and 2 tell us is that there's an X and it goes right here. Okay, but if the X goes right there, then what does that tell us? That tells us that at least one of Mary's children is a daughter. Mary has at least one daughter. Maybe she has more than one daughter, but we know, based on the information contained in premises 1 and 2, we can conclude that she has at least one daughter. We know that for sure based on the information contained in premises 1 and 2. So, if the information contained in premises 1 and 2 is correct, then Mary must have at least one daughter. And so the argument is valid. And the Venn diagram shows us that the argument is valid, because once we visually represent the information contained in premises 1 and 2, then we can simply read off the diagram that the conclusion is true. We can read off the diagram that Mary has at least one daughter. Okay, now let's see if we can apply this technique to the other arguments of the same form that we considered at the beginning of last week. Remember, we considered an argument concerning Terry. Premise 1 was, Terry has a job in which she arrests people. Premise 2 was, only police officers can arrest people. And the conclusion of those two premises was, therefore, at least one of Terry's jobs is as a police officer. Now, how would we visually represent the information contained in the premises? Well, let's consider. Premise 1 tells us that Terry's jobs includes a job in which she arrests people, right? So at least one of Terry's jobs has to be in this circle, because whatever else it is that Terry does, she has a job in which she arrests people, so at least one of her jobs must be in this circle. And of course it has to be in this circle, because that's the circle of Terry's jobs. So at least one of Terry's jobs must be in this football-shaped region right here, in this intersection of the category of Terry's jobs and professionals who arrest people. That's what premise 1 tells us. But again, it doesn't tell us where that particular job of Terry's would be. Is it here or is it here, right? Premise 1 doesn't give us that information. But what does premise 2 tell us? Well, remember, premise 2 tells us that only police officers can arrest people. So, how would we visually represent that? Only police officers can arrest people. That means that there's, in the circle of professionals who arrest people, we have to shade in this part, because there are no professionals who arrest people other than police officers. Only police officers arrest people. So we shade in that portion of the professionals who arrest people circle. And now remember, what we learned from premise 1 was that Terry has a job in which she arrests people. So somewhere in this football-shaped region, there has to be an X. But we know now that it can't be here. So the X must be here. So that's the information that we get from premises 1 and 2. But notice, once we visually represent that information in our Venn diagram, then we can simply read off the Venn diagram that Terry has a job, at least one job, in which she's a police officer. So at least one of Terry's jobs is as a police officer. And we can just read that off the Venn diagram once we've used the Venn diagram to represent the information contained in premises 1 and 2. So the Venn diagram, again, can be used to represent the validity of the inference. And not only that, notice also that the Venn diagram for this inference is the same in the placement of its shading and its X's as the Venn diagram for the previous inference about Mary. Well, what does that tell us? That tells us that the two inferences, the two arguments, are of the same form. They're of the same form, and you can see that by seeing that their Venn diagrams look the same. The only difference between the two Venn diagrams is the labeling of the circles, is the categories, the specific categories involved in the arguments. Other than the specific categories involved in the arguments, the labeling of the circles, everything else is the same. The shading is in the same place, the X is in the same place. Okay, now, can we apply this to our third argument about Robert? You'll remember this third argument that we considered of the same form at the beginning of week 4, at the beginning of our unit on deductive logic. remember, we considered an argument that went like this. Premise 1, Robert has a pet who is canine. Premise 2, only mammals are canine. Conclusion, therefore, at least one of Robert's pets is mammal. Okay, well, how would we visually represent the information contained in premises 1 and 2 of this argument? Here's how. At least one of Robert's pets is canine. So that means that whatever other pets Robert has, right, maybe Robert has some non-canine pets, but at least one of Robert's pets must be in this circle. Well, that particular pet that we're talking about has to be in this circle, but of course it also has to be in this circle because this is the circle of Robert's pets. So the pet must be in this football-shaped region right here, the intersection of Robert's pets and canines. But where is it? Is it here or is it here? Well, now let's look at premise 2. What do we find out from premise 2? What we find out from premise 2 is that only mammals are canine. Okay, well, if only mammals are canine, then that means that there can't be any canines outside the circle of mammals, right? All the canines, whatever canines there are in this region right here. There aren't any canines outside the mammal circle. So, we know that whatever canines there are have to be in this intersection right here, the circle of canines and the circle of mammals. And we also know that that Robert has at least one pet in the circle of canines. Okay, well, if Robert has a pet in the circle of canines, and we also know that there's nothing in the circle of canines that's over here, then we know that Robert's pet, which has to be in this circle, right? This is the circle of Robert's pets. Robert's pet has got to be in here, right? The pet that we're talking about, the pet that's canine, has got to be in there. Okay, so that's a way of visually representing the information contained in the two premises of our argument. But once we visually represent that information, we can just look at the diagram and read off the fact that at least one of Robert's pets is mammal. Because at least one of Robert's pets is inside the circle of mammals, right? Inside this circle, which means that at least one of Robert's pets is mammal. But that's exactly what the conclusion says. And so, this Venn diagram shows us that this argument about Robert is valid, just as the arguments about Mary and Terry were valid. And furthermore, this argument about Robert is valid for the same reason as the arguments about Mary and Terry were valid. They're valid not because of their subject matter, right? The three arguments have completely different subject matters. They're valid because of their form, and their form is what's revealed by the Venn diagram. The form is what's in common to the three Venn diagrams. The placement of shading and X's in the Venn diagrams is their common form, and that's what explains why all three of the arguments are valid. Okay, see you next time.